morning, JSpring. It's nice to be here again. I was here last year as well, just like many of you. I'm very happy to see that. And I was just told that maybe it's a good idea to talk about in this presentation why the nice weather just won't come. But, I already made my presentation, so I think I'll skip on that. And what I will talk about today is I'm going to tell you a story that I experienced that really changed my life as a developer, and in particular helped me discover a new way of dealing with performance bottlenecks based on some things I've experienced in the real world. And I think it's a very fun topic. My name is Lennart and Wolde. I am a software engineer. I work for Chillit. Chillit is a sponsor here today because we care about technology, we care about Java, and we love JSpring and JFall. We are a company that's not only for developers, but also ran by developers. Our founders are developers, so we are really passionate about sharing knowledge with each other, and that's why we love things like this. And I love doing things like this, and I'm very happy to be here today representing Chillit and hopefully telling you all an interesting story today. So that's what we do, and that's what we stand for. So why does performance matter in the first place? Because I know a lot of people might say, well, performance, it matters to some projects, but not to most. Well, I beg to differ. There was a case I was working on for a client a number of years ago that was related to interest-only mortgages. And if you can't read the Dutch on the slide, don't worry about it. The essence is that we had a lot of clients, old customers, with mortgages where you don't pay the principal, you only pay the interest, and at the end, you have to pay the entirety of the principal. It's an interesting mortgage structure that's no longer as common today, but a lot of people still have it. And as it turns out, according to research, 40% of people hadn't thought about what they're going to do when their mortgage ends. So the Authority Financial Markets, AFM, work together with banks in order to create some new regulation to help customers be aware of the consequences of their mortgage, help them inform what their options are so that when their mortgage expires that they're in a more comfortable financial situation that they've prepared for. So what does that mean? Well, we had an important task with broad socioeconomic impact because we had to communicate with these customers and give them personalized advice with a pretty tight constrained deadline set by the AFM that you want to meet not only because there's financial penalties involved, but also because you want to be there for your customers. And there was a large volume of existing data originating from old mainframe machines because that's what these mortgages originally were created in. Most of these are old mortgages. So, plenty of challenges. And what we wanted to do was make a process that takes all of this data from an export, because it was a mainframe system. Think of it like a CSV. And we enrich it with some data, after which we send it to an AWS Aurora database so we can perform analysis and determine which customers we have to send out a survey and give advice on how to navigate their mortgage. So we built this. It was, everything was going pretty well. We decided to go live eventually after we had tested things thoroughly and things seemed to be going well. We had an idea of how good the performance was going to be, but this is a process that ran just once a month, importing a large set of data. So we didn't think that was going to be too much of an issue. You have essentially no time constraints at all. Yet we did run into an issue when we went to production. So what we saw on acceptance and when we were testing is that everything was going well, but you go live, and it just kind of seemed like nothing was really happening. We started the program, and admittedly, we should have logged more messages to the console so we know what the system's doing, but it just wasn't really doing anything. And this kind of thing usually happens in production, and it's the worst time to have an issue. It's really frustrating because you don't know where to start, and you have an important deadline. Just imagine maybe the deadline is even more intense where you're migrating from one infrastructure environment to another. You can't really go back. So this is the worst time to have problems. And then you begin to troubleshoot. first you make an assumption, okay, the program isn't working because of this, and you fix it, and obviously it doesn't work. So you log, you try to get more output from your system. You get too much output, so you have to reduce it again, because now you see it's doing stuff, and our system was doing stuff. It was importing mortgages and putting them in the database, so we don't know what's wrong. And then eventually you're like, okay, well, I see something. It seems to be slowing down as time goes on, so you try to investigate some suspected bottlenecks, but you really have no idea. And then you just think, well, maybe we need more resources. But most of this stuff didn't actually fix the issue, and it can cost a lot of time when you're unprepared. So what went wrong, really, when we made this application and went to production? Well, I don't have the exact data anymore, but it looked a little something like this. Imagine there's a graph, and we're talking about the performance of inserting each new record into our database, right? So we go over a list of different mortgage entries with a lot of customer information, we want to insert it. And the first few thousand entities that we insert are fast, and then it just seems to get progressively worse. And near the end, we're talking about 10 seconds for inserting a single database entry. So this is the kind of thing that you're very unlikely to catch when you're still developing something. And what we did was a little similar, like you might implement a similar program, a little something like this, right? You read some data from an export, maybe a CSV, and that could be an area where it goes wrong. Maybe you're reading the entire file into memory at once, so that's a potential issue. Then you query an existing entry that you want to update it and save it back to the database where you're using a framework. Maybe you're using this framework incorrectly, Hibernate in this case. But what really happened in this case was the use of transactional. So we had a database transaction. And what we thought is create one transaction at the start, insert a few 100,000 records, and then commit. And if it goes wrong, refer to the start. You know, you have less overhead for making many different transactions, so this made logical sense. It should be faster too, except it wasn't. But you know, they don't teach you this in school. So I tried to replicate a similar issue recently to see if I could still see this issue occur again. And so I did, and there's a really big dashboard here. I made one in Grafana. But if we zoom in on one metric I created in a little test application that inserts random records into the database, you'll find that the amount of time it takes to save entries is very low and stays constant. But querying for existing entries takes progressively longer as we add more entries into the database, almost as if the indexes aren't working properly. And so the throughput of how many records we insert starts at 150, and then by the end it's down to 15, so that's a 90% reduction in just half an hour of putting this program on. And of course, if I kept it going longer, it would get even slower, but you know, nobody has time for that. So what do we have to do? Well, the solution was pretty simple in this case. We created one transaction for each row. So each record we insert in the database, separate transaction, and this should have really taken 5 minutes to solve. Oh, this is the issue, fix it, boom, done, production, no issue at all. But it didn't because we weren't well prepared. So really what we did, if this is your original code to insert data, we just kind of did this. You know, 2 lines of code, boom, done, that's it, issue fixed. And then what does your data look like? Well, now it's consistent. We're talking about microseconds instead of milliseconds, and well, you know, it takes just 2 minutes now to fully process the data set instead of 30. And this is a small test data set I made on my own laptop. But one thing that you'll find that's interesting is that the throughput now actually goes up over time instead of down. And that's really what you expect to see. But sometimes there's an issue. But what I want to emphasize is that there are always more bottlenecks you can solve. So this little test case I made took 2 minutes. I took a slightly larger test set and tried to replicate it to look at what can I do to make it even better. Right? You might do batch inserts, where you insert multiple records at once, so you reduce the amount of round trips to the database. You can even query all the entries you're going to update in batches as well, further reducing your round trips. You can try to utilize some concurrency, but you do have to be careful not to exhaust your connection pool and apply back pressure. There's some complexities with that, but if you really need the performance, it's an option. And so I actually tried this, because I was curious, you know, what if you do these things? So this was the solution, one transaction per entry. I ran a test with 70,000 randomly generated records, and it took 9 minutes and 35 seconds to insert into a remote database. Then I tried to create one transaction per 50 entries, because there is transaction overhead, but just don't insert too many in one transaction. And 2 minutes reduced, so we're 26% faster now. That's pretty good, and our code essentially hasn't changed. You can try to insert 50 entries at once, and it's 3% faster. It's kind of the same. Well, this is when I found out that I made a little mistake. I was using JPA to batch insert data, and it turns out there's some properties you have to enable in your configuration for it to actually really insert your batches as batches. So when you try to improve the performance, actually validates that what you're doing is working and is actually making things faster, because after fixing that and using the correct primary key generation, we were down to 2 minutes 55 seconds, and again, this is for processing 30,000 records, so 153% faster. And then, of course, you can also query all of the existing entries at once, so now we're down to 32 seconds, 430%. And just for fun, I thought, why not? It's very easy to do. I try to do this concurrently with parallel streams. Not the best way to do it, but it works. And now we're down to 2.9 seconds, so an additional 1,000% faster. And if you try to resolve these 4 more bottlenecks, you get a 19,066% performance increase over the initial solution. So what I'm trying to demonstrate with that is that there is always a bottleneck in your code. The only question is, when are you done solving them? When do you decide enough is enough? So what can we learn from this? Well, you should be careful about how you use transactions and test with realistic workloads before going to production, especially if you have an important deadline or there's no easy way to go back if it doesn't work. Test with realistic workloads if at all possible. And that means realistic numbers too. You should collect plenty of useful metrics, like I showed some dashboards, so that you can do a quick diagnosis when there is an issue, and you know already which part of your application is slowing down. So you can do a targeted search on what to fix, instead of trying to guess and look around and change your logging and do a whole bunch of deployments that are slow. And that's what we can learn from it. So then, what are bottlenecks exactly? Is how I want to end off my talk today. Because the way I see it, bottlenecks kind of exist in a hierarchy, where when code is running, obviously it's running on the CPU. The CPU is performing instructions. But sometimes the CPU has to wait on data, and this data can either come from cache, RAM, disk, or network round trips. And obviously the cache, which is hardware controlled, is the fastest, RAM is slower, and network round trips are by far the slowest. So if you have a bottleneck in this area, most likely all the other bottlenecks don't matter as much. And there always is one, so try to have a good understanding of what the bottlenecks are in your application before you go live. And eliminate bottlenecks until you reach your performance target, but don't prematurely optimize, especially if you're new, because sometimes the solutions to making your code faster also makes it more complicated. I'm sure everyone who's tried to play around with reactive programming or concurrent programming knows that there are some challenges to doing this, so you only do it if it's necessary to reach your performance targets. But you do want to stay one step ahead by knowing where are my limits and what kind of throughput do I expect, so that you can determine what kind of optimizations am I going to make and which ones am I going to leave out. And now it's up to you to use this information and determine which issues am I going to solve, and use that in your day-to-day work to prevent running into the kind of issues that I ran into in what could have been a big disaster. But fortunately for me, it wasn't. And so I'm going to go back just for a second. I actually have a second presentation a little bit later in the day that talks about more of the diagnostic side of this. So how can we find these issues in advance? How can we get good metrics on our performance, as well as more complex examples showing you what kind of issues can you actually run into. and how can you address them, both with concurrency and your database and load tests. So if that's the kind of thing that interests you, you'll see it in the app. I think it's like a little bit later in the day, maybe not the session after this, but after that. Go see it if you're interested. I would love to see some people there. And regardless, we from Chillit are happy to be here today as a sponsor. We have a QR code, but it's all over the place. You don't have to scan it right now. You can use it to get ice cream, poffertjes, or sign up for a hot sauce challenge. And we just really want to talk to developers because we're all social creatures. We like talking. We like hearing about your thoughts on maybe the keynote, performance, or other things you run into in practice. And we just want to have a conversation because, we like talking to people like us, and we like sharing knowledge and learning about the things that you've maybe gone through. So thank you so much, and I hope to see you later today, and I hope to see you at the stand. Thank you.